Hi, can everybody hear me? Welcome to the Java 8 webinar sponsored by eSynergy Solutions. For anyone that doesn't know eSynergy Solutions, we're an IT recruitment company specialising within the open source market for both contract and permanent placements. We place across the full project lifecycle, which includes architects, developers, sysadmins/DevOps, testers through to senior appointments like PMs and BAs. I'd just like to take this time to also introduce myself. I'm Neil Perkins, the open source team leader and senior consultant. At the moment, as well as being really well involved in the community, we also have a lot of contract and permanent exciting opportunities throughout London and the UK. Any candidates looking within that market, feel free to contact me. And on the flip side of that, any clients also looking to hire any talent within the markets I've just specified, please also get in contact, because we've got some excellent candidates available at the moment from building our community, such as doing things like this. So I'd also like to basically pass over now to Raoul, who will be doing the Java 8 webinar for us. I hope you'll enjoy it, and as I say, get in touch if you need to. Thank you very much.
All right, good evening, everyone. My name is Raoul. Could you, before we start, could someone put in chat box that they can hear me very well? That'd be useful before we get started. So there's quite a lot of you guys attending this webinar today. This is very exciting. All right. Yes, we can hear you. Shakshi, thank you very much. So today we're going to talk about functional refactoring in Java 8. So both functional programming and Java 8 are really hot topic in the moment. So, you know, when we talk about functional programming, you might have this this idea in your head, right? Maybe someone very academic with some crazy terminology such as first-class functions, immutability, you know, someone a bit beardy, maybe wearing sandals. And, you know, there's some rumors that says the more beard you have, the more functional you can be. And today, what I'd like to do is to kind of shed some light on all these concepts. So, you know, the day-to-day developer looks a little bit more like that, right? We're all happy. We don't need to know any crazy maths or research to do our day job. So what we're going to do is, well, shed light on those functional programming concepts and show some concrete examples of how you can use those concepts in your code. The first one is first-class functions, followed by immutability, and finally optional data types. So I'd like to do things a little bit differently. So instead of providing you with the definition of each concept and then showing you some examples, I'm going to do it the other way around. So we'll start with some use cases, developing them, and at the end extract what the functional concepts are. So let's take this this little piece of code. Let's say we've got an inventory of invoices. So we have a list of invoices, and your boss is telling you, well, I'd like to find out about all the invoices coming from our customer Oracle. Well, so you write this this code, which is quite simple. So it iterates through all the list of invoices passed as an argument to the method find invoices from Oracle. For each of them, we check if the customer is actually Oracle, and then if it is, we'd add it to. So once the iteration is done, we can return that result. So this is all very nice. Well, now let's say your boss comes back to you and says, you know what, the business is really going really well. We've got Google as a customer. Well, so if you have Oracle and Google as customer together, then you're doing well. But you might have also eBay, Facebook, eSynergy solutions, and so on. So what can we do to cope for those requirement changes? Well, a really bad idea would be to kind of copy-paste this method and just rename it find invoices from eSynergy solutions or find invoices from Google. And maybe just change that if condition in the middle, which is the only difference that we need. Unfortunately, if you do that, then suddenly you have to maintain many different methods that actually are very similar on the customer. So let's take a nice software engineering hat and let's figure out how we can cope for those requirement changes. So when we've got troubles, we always have to call abstraction. So what we can do here is introduce a new parameter to the find invoices from customer method, a customer parameter, and just update the if condition accordingly. So as a result of this change, by introducing a new parameter and abstracting, we can cope for any requirement changes that involve a customer. We just need to pass the customer we're interested in as an argument to this method. So this is really awesome. But is that the end to the story? Well, now your boss again comes back to you and says, well, you've done really great work, but we'd like to have something a little bit more complex if possible. So let's say so we might have invoices related to training. We might have invoices related to consulting or some other gigs. So how can we find those invoices? Well, we copy our previous method that iterates through all the list of invoices, and we introduce a different parameter. So instead of the customer, we're interested in finding invoices that end with a suffix. So we introduce this suffix parameter to the method, and we update our condition accordingly. So now if your boss comes to you, well, we can cope for any requirement changes that involves a suffix. So this is really great. Well, is it? Unfortunately, we still have two methods that are very similar. They all iterate through this collection invoices, apply a condition on it, and add it to a result. So it would be great if instead of maintaining two methods, we to avoid code duplication. So here is one way to do it, and I really do not recommend to do it. So this is an example of a messy code reuse. So well, we could merge those two methods together and introduce a flag. So this is the parameter called flag that has type boolean. And based on that flag, we can now decide whether we'd like to do the finding, the filtering based on the customer or based on the suffix. So, okay, it's all good me telling that it's not nice, but what are some specific reasons why it's not nice? Well, what if your boss comes back to you and says, well, invoices don't only have a customer suffix. They might have a price, they might have a date, they might have a list of agreements that you'd like to query. So this solution really does not scale for multiple properties of an invoice. So again, we call a friend the software engineering hat, and we try to figure out a better solution so we can code for any requirement changes. And as you know, the answer to that is always to call abstraction. So we need a way to model this sort of criterion that we like to specify on an invoice. So here we introduce an interface called predicate, which will model this idea of a function that takes an invoice and returns a boolean. And by the way, this predicate interface here is now available out of the box in Java 8 under the java.util.function package. So how can we use this new abstraction to help us? Well, let's refactor our code as follows. So we take our find invoices method and we introduce the predicate as a parameter and we update the condition bolded in black in the middle. So this is really great now because all we need to do is to pass a predicate argument to find invoices, and that will specify what sort of condition we'd like to specify on the invoice. Well, how can we create those sort of predicate objects? Since it's an interface, we can create a class that implements it. So in this example here, we'd like to find out about invoices that come from a customer Facebook and are related to training. So we create a class called Facebook Training, which implements the predicate. We provide the implementation of the test method, which takes an invoice as an argument. And the body of the test method implements what condition we like to operate on that invoice. So in this case, it's very straightforward. We check if the get customer is a Facebook and whether the suffix is training. So let's reflect just real quick on what we've done so far. So we've come from a method called find, so a very, very rigid method that doesn't come for requirement changes, to a new method called find invoices that can come for any requirement changes involving all the properties of an invoice. So this is really awesome. But there's still a problem with this solution. We've gained a lot more flexibility and abstraction at the cost of conciseness. So our code now is really a lot more verbose, right? To specify a single predicate, we need so many lines of code. So the intent of it is kind of hidden through this Boolean test method, through this implementation of a interface and so on. So can we do better? Can we win both on flexibility and conciseness at the same time? So now we'll refactor this code using some Java 8 features. One of the Java 8 features is called method references. And it works as follows. Defining two methods, one called isOracleInvoice. So it's just a normal method like we used to. It takes an invoice as a parameter and has a Boolean return type. And the body of the method says whether the invoice passed as an argument is from Oracle. And similarly, we can do the same with isTrainingInvoice. So now in the code that follows is really the method reference feature. So we can pass the Oracle invoice method as an argument to the find invoice method. And this is done through a special syntax. So we say this : is Oracle invoice. And this syntax means we are not making a method invocation. You know, you'd use a normal dot for that, but instead we'd like to pass that method as an argument. And we're doing the same thing with isTrainingInvoice. And this code will work just like before. So we will call or we'll find invoices that are related to training. So our code is looking a lot more concise now, isn't it? Well, is there anything else we can do? Well, Java 8 also introduced a new feature called a lambda expression. Functions as an argument to another method. So the problem with method reference is that if you want to pass it as an argument, or if you want to use it, you need to have that method declared. So we had to declare a new method called isOracleInvoice or a new method called isTrainingInvoice. And in cases where really you just want a little throwaway piece of code, then it's not very convenient to have to So this is what lambda expressions are for. So in this case here, we pass a lambda expression as an argument to find invoices. Make sure that it's from customer Oracle. And the second case, given an invoice, make sure it's related to training. And by the way, if you're wondering why there is no parameter type in this lambda expression, it's because Java 8 has a type inference mechanism. So we don't have to say that the invoice variable here or parameter is actually of type invoice. Java 8 can figure it out for us. So what is the takeaway? Coming back to functional programming, what is really the takeaway here? So this idea that we've just seen of passing a method or a lambda expression as an argument to another method is what we call first-class functions. So, every day we pass a string as an argument to a method, we pass a number, or we pass different objects. Now you can pass a function as well through using method references or lambda expression. And this is really what first-class function means. So it's a scary terminology. And it's really useful for us as software engineers because it helps us cope for requirement changes where a new requirement can be represented as a function. So a related topic is that of composing functions. So I really like this analogy of the Lego blocks to explain composing functions. So by the way, let's have a quick raise of hand. So raise your hand if you've played Lego before. Fortunately, I cannot see you through the webinars, but I'm pretty sure all of you have your hands up right now. If I was asking as well, if you're still playing with Lego, I'm pretty sure a few of you guys would still have their hands up as well. So the way I like to think about functions and Lego blocks is, well, a Lego block is just a simple function. So individually, those pieces are quite interesting. They've got pretty colors and they can do things. But it's really when you put those blocks together, build really complex designs. Build a really great castle, for example. And this is what composing function means. It's taking a few functions and gluing them together to build a richer function. So let's see how this works. So again, this code is written using Java 8 features. So we import the predicate interface, which I introduced in the previous slides. So it's available in the function java.util.function package. We have a method reference to a method called isFacebookInvoice. We assign that to a variable called isFacebookInvoice. So this will have the type predicate. And then we'd like to filter all the invoices that are both from the customer Facebook and related to training. So this code here uses a new API called the Stream API, but that's not very important for now. Let's just worry about this filter method. So in this filter method, well, we'd like to create a new predicate, which is the composition of isFacebookInvoice and this other method which we define, which is called isTrainingInvoice. And this is possible because the predicate interface in Java 8 supports this AND method, here bolded in blue. And we can do something similar, let's say if we'd like to find out invoices that are either from Facebook or from Google. Well, we just need to use this other method called OR. Right, so at this stage, we should all be thinking, wait a minute, Raoul, how come we can have those methods inside an interface? How does that work? Well, let's look at how the predicate interface is defined in Java 8. So this code is pulled from the JDK source code. So as we know, as we shown earlier, the predicate interface which takes an object type T and returns a boolean. And then we've got those two methods which you saw in the previous slides, AND and OR. And they work as follows. So AND takes a predicate as an argument and also returns a predicate as a result. So in a sense, AND takes a function as an argument and also returns a function. And the way this works is by saying, well, let's return a lambda expression, which takes an element of type T, so in this case it would be an invoice, and does two things on that element. It tests it with the current implementation of test, and then use the AND operator to test it also with the predicate passed as an argument. And we can do something similar with the OR method. So now you may be wondering, well, wait a minute, okay, that sounds all right, but that looks to me like an abstract class because we have implementation code inside. Well, in Java 8, interfaces themselves can have implementation code as well. And this is done by introducing this new default keyword. So you can see before the result type of those two methods, there's a new default keyword. And that lets us have implementation code inside interfaces. So to really illustrate the benefits of using composing functions, so we're using existing implementations and piece of code to compose richer and more complex ones. Let's look at this use case. So here we've got an email class. So a very straightforward implementation. There is a message that you'd like to send, and you might want to add a header to your email. You might want to do some check spelling, and you may want to also add a signature to it. So I see there are a couple of questions, including from Thomas, and I will pick them up at the end. So feel free to write down your questions in the chat box, and I'll come back to. So to come back to these use cases, so we've got three different methods: add header, check spelling, and add signature. And we may be interested in doing different sort of processing on those emails. We may want to sometimes add a header, sometimes do spelling, sometimes both of them, or maybe even add a signature. So we'd like to create what we call the sort of processing pipelines. So pipelines, it's a very buzzy, trendy word these days, but really it's a very old concept. So if you're familiar with Unix commands, it's the idea of running a program and piping the output of this program as the input to another program. This program will produce an output which then becomes the input of another program. So typically you might want to say cat, that becomes the input to the sort program, and then you might want to truncate that result as well. So how can we do something similar in Java 8 using function composition? Well, there is another interface in Java 8 called a function. See what it represents. Something that takes an input, here an email, and that will also produce an output. In this case, also an email. So using the method reference feature that you've seen earlier, we can assign that into the add header variable here, and then we can create this sort of pipeline. So the function interface supports an and-then method, which takes another function as an argument. So the result of that will produce a function itself. We can then compose it with the email add signature. So what we've done here is creating a processing pipeline that has three components to it. Starts with an add header. So if we've got this input called Java 8 FTEW, we compose that with the check spelling. Then we compose that with the add signature. And the result of it will be as follows. But let's say if we want to have a different processing pipeline, well, what do we do? Well, again, we can call a function composition and create another pipeline. We just want to add a header and a signature. So again, we call this and-then method that is defined as a default method inside the function interface. Right, so that was it for the first topic of this talk called first-class functions. And we will now talk about another topic which is related called currying. So I realize that, it's past 6 o'clock, we all want to get dinner, but unfortunately we're not going to talk about food, even though this technique is called currying. So let's look at an example of what currying is. So here we've got let's say, it's a very typically for scientific applications to do conversions between different units. For example, we may want to convert Celsius to Fahrenheit. If we work in the financial industry, we may want to convert between different currencies, and so on. In general, the formula for doing this type of conversion works as follows. We have the amount that we like to convert. Then we apply a conversion factor to it, and we may want to, have a baseline adjustment. And this is what this convert method represents. So we could call it as follows, for example, to convert 10 degrees Celsius into Fahrenheit. And the result here would return 50. So far so good. So if we like to do conversions between different units, well, we can always pass the conversion factors, the amount, and the baseline adjustments. So here, again, an example to convert from Celsius to Fahrenheit. We might want to convert something even of a higher temperature. We might want to convert from dollars to pounds, or kilometers to miles. So this convert function method is not really satisfactory, is it? If you look at this temperature example, we always have to type in the conversion adjustment. So this is a bit tedious. Ideally, we like to reuse those conversion factor and baseline adjustment. We don't want to type them again. So what we could do is, we'll define three separate methods. Called, convert to Celsius, or Fahrenheit, converts to pounds, and convert to miles. But if we do that, then all those methods actually have exactly the same implementation. Ideally, we like to reuse the logic of the conversion. So these are the problem. One is we'd like to have better reuse of code, and also we may want to be able to abstract on the different conversion. What if we'd like to pass a different type of conversion to another method? So how can we do this? There's another question coming up. So again, I'll come back to the question at the end of this talk, so keep them coming. So how can we solve that problem of reuse of code and abstraction? So let's introduce currying. So here on purpose, I've put a nice picture of great food to go in with currying. So the idea of currying is that instead of having one function that has multiple arguments, really a sequence of arguments like the conversion function I showed earlier, is to have a function that has one argument which returns another function. This function itself will take another argument which returns another function. So in a nutshell, it's kind of the idea of having a factory of functions. And this is what this picture entails. So you can think of a dish that has all the different ingredients mixed as a traditional way of having a method. But if you split up all those different dishes separately, this is what currying is. It means splitting up the arguments of a function. So how does that work? So let's come back to our convert example. So here I've refactored the converting 3 arguments. It only takes 2 now. It takes the conversion factor and the baseline adjustment. And what it does is return a new function as the result type. So in this case here, it's a function that takes an amount and then applies the conversion logic. So this is really cool. So we've got this convert that takes 2 arguments and now return a separate function as argument, which means we could call it as follows. So if I'd like to create a function that is responsible to convert from Celsius to Fahrenheit, I can now call the convert method as follows. I pass it in the conversion factor, 1.8, and the baseline adjustment, 32. That creates me a new function. And then I can call that function, let's say I'd like to convert 10 degrees Celsius into Fahrenheit. I can call this method called apply as double. So you may be wondering, well, okay, wait a minute, what's that ugly double unary operator interface that is part of the Java 8 API and the function? And when we need to call it, we can call this apply as double method. So it's important to know that the Java 8 API ships with a lot of those function interfaces that are useful. So another scary functional programming terminology is called partial application. And it goes really hand in hand with currying. So currying is the idea of splitting up the arguments of a function so they return a new function as a result. Partial application is the idea of feeding the parameters to that function. So if I come back to this slide, partial application is when we pass 1.8 and 32 to the convert method, whereas currying is this declaration where we've split up the amount argument and instead we return this as a function. So here are some other examples. So now if we'd like to have a way to convert from dollars to pounds, well, all we need to do is to create a new function for it. So we have a factory that creates the conversion function. So we pass it the conversion factor and the baseline adjustment, which is 0. If we want to convert from kilometers to mile, well, again, we can call our convert function, which acts as a factory to create functions. And this is really great now because one single method called convert encapsulates the logic of the conversions. And every time we need a new way, a new function to do conversions, we just need to call it, instead of passing the same parameters multiple times. And we've also abstracted what a conversion is through this double unary operator. Right, so let's summarize what we've seen on currying. So this is another functional programming terminology. And what it means is splitting up the arguments of a function, whereas partial application is in some of those arguments, so feeding the arguments to the function, which then returns a new function as a result. So I'm pretty sure we are all really hungry. So there's a question that can we call it function factory? Well, I like to think about currying as a function factory. But if you tell that to the academic functional programming guys, they might not like it. But personally, I think that's a great way to think about currying. It's literally a factory of functions. So let's talk about the third topic of today's webinar, which is immutability. So what's that crazy word about? So, well, there's actually two crazy words. So one is called mutable, the other one's called immutable. So it has nothing to do maybe with biology, where we want to be immune with things, or mutants and so on. Objects is the idea that once we create an object, we can still modify it later on. And this is what we typically do on a day-to-day, right? So in this code here, I'd like to represent a train journey. So a train journey has a price and has a onward journey. If it didn't have an onward journey, then we could set that field to null. So we've got a constructor for it, which takes the price and the onward journey. We then have two getters, the get price and get onward. And then what's interesting is that we also have two setter methods. So if we'd like to change the price of the current train journey object, we've got those two methods to do it. And this ability may not be always convenient. So let's say you have a friend called Jerome and you have a friend called Christophe. So if you pass a train journey object to Jerome, some problems could happen. So if Christophe decides to update the price of the journey, then Jerome will see that change as well, right? So he's suddenly been able to update the price of Jerome's tickets because they share the same object. Well, there is another school, a different way of thinking called immutable object. And it's the idea that once you've created an object, you should not be able to modify it. You should not be able to modify its state. So now how does that work? How can we make a class immutable? Well, Java has a modifier called final, which we can add to our fields, and it's in Java good practice. And it means we can reassign to those fields. So once I've defined a price field to be final, then no one can modify that field anymore. Well, what if we want to, maybe update the onward journey? What do we do? Well, instead of having those two setter methods, here we've got these two methods called with price and with onward. And what they do is they create a new copy of the train journey and gives the updated price and gives the current onward journey. And with the with onward method, we do the other way around. So one thing to also realize is that if we define our fields to be final, it doesn't mean we can't modify them. Let's say we had an array as a field to the train journey immutable, for example, an array of prices. Well, even though we can't reassign to this field, we can still change the content of that array because the array is mutable. So we always need to ensure that the final is transitive. So every single objects within the fields are also immutable themselves. And one great benefit of immutability is that for publications. So if we got, let's say, an application with multiple threads, we don't need to worry anymore about, wait a minute, I think my thread here made a change to this object, or is it the other one? We get those data races. This problem cannot occur anymore because the objects cannot be changed. So let's look at an example of how we can benefit from adopting immutability in our code to reduce the scope for bugs. So here's the scenario. We like to link together two train journeys to form a longer one. So I'm going to start with some diagrams and then I'm going to show the code for it. So one way to do it, which is the mutable approach, is to say, well, given a start journey represented as a linked list here on this diagram, and the cross represent null, which means, well, this is the end of the journey, and another continuation journey on the right side, well, just to link them up, we need to change the state of the points to the continuation journey. So how does this look in code? Well, here's one way to do it. So given the start journey and the continuation journey, we return the continuation journey if there is no start journey, so we check if it's null, otherwise we just return the continuation. And then here in the middle of this code, we iterate through all the onward journeys until we find the last one. If we found the last one, we know that this is the one we need to link up with the continuation journey. And this method here called setOnward will change the state of that train journey object and set it with the continuation. So this is just a standard way to link a linked list. So are there any problems that can occur with this practice? Well, let's say if we take the start journey and the continuation journey, if we link them up once, that will return, a longer journey. If we do it again, it's safe to assume that that should return exactly the same journey, right? So to see what happens in practice when we call this code, I've got a visit method here that takes a train journey as an argument, and this type of consumer object, and it'll basically recursively print all the prices of the train journey. So basically that enables us to iterate through that long list of train journeys. So if we execute this code, what do you think will happen? Well, let's call our friends the diagrams again to visualize what happens. So initially we've got two train journeys, the start journey and the continuation journey. We call this link method once. And as we've seen previously, that will change the state of the start journey and link it up with the continuation journey. So this is the step in the middle. When we call the link journey again, what is going to happen? Well, we've mutated the start journey, so we need to iterate through the end of it until we find the stop, which is this cross, the node. So we do that, and once we've reached it, here we decide to, well, okay, we need to link that up to the continuation journey now. So we change that state. And by doing this, we've introduced a cycle in our linked list. And this is why this produced a stack overflow, because the iteration was done recursively. If it was done just using a loop, then the loop would go on forever because there's no stop journey. So that's really nasty. That's the type of problem that is very difficult to predict. So there is another way to solve this problem, which is the immutable way. And the immutable way says, well, you should never really modify the arguments passed to a method because, you know, your client, you should never mess around with it. So instead, let's create a copy of those arguments if we need to modify it. So in this diagram, instead of modifying the start journey in place, instead of mutating it, we create a copy of it, which we then link to the continuation journey. And that would be the result of the link operation. And it turns out there's a concise way to write this in code. So here's a refactored link method, which will copy all the start journey nodes and then link it to the continuation journey. And it works recursively by creating a new train journey object. So there's a lot of related topics to immutability. So it's worth mentioning, you know, it's not a new way of doing things. You know, several classes in the Java API, such as string, is immutable. Integer is also immutable, and so on. And the Java 8 API, specifically the new date and time library, has been designed around this object. Because if you think about it, a lot of the bugs that occur with the previous date API is that, well, if I have an object date that says it's Thursday, I could change that object to Friday. But someone else in your code might be still thinking, well, I thought it was Thursday, so it doesn't really make sense to be able to mutate a date. So instead, what the new date and time API does is when you want to change the date of an object, it creates a new one with the updated value. But the two versions still exist in parallel. Java 9, or more specifically Java 10, have a proposal to add this idea of value types, which means a class you define could be checked at compile time that it's completely immutable. There's a lot of tooling that can help you to make sure that your classes are mutable, such as the mutability detector and find bugs. So to conclude this topic, immutable object basically reduce the scope of, you know that this object cannot be changed by some other people in your code. All right, we're coming to a final topic of this talk called optional data type, which is another feature of functional style programming. So don't we all love null pointer exception? If I was having a little raise of hands again, I'm pretty sure everyone would say, yeah, I regularly get null pointer exception. And the worst is that they always come, you know, at bad times. Typically on a Friday afternoon, you know, you've pushed your last commit, ready to hit the pub, you're on your way to the pub, you order your beer, and suddenly you get a notification by email, well, there is a null pointer exception in the application. And you have to go back to work. So this is really annoying. And to show an example of how common null pointer exceptions can be, let's take a look at this code. Here we've got a simple method called getCar insurance name. So it takes a person as an argument, and we'd like to return the name of the insurance of that person's car. So here's a quiz. Where is the null pointer exception? Well, if a person was null, then we'd get a null pointer exception. If getCar was returning null, then we'd also have a null pointer exception. If getInsurance was returning null, then we'd also have a null pointer exception. So really, this is very annoying. And there are some rumors that Wally, depicted in this slide, was so fed up with the null pointer exception, he decided to, you know, quit his job and hide in large groups of people to never be seen again. So how can we help Wally and us on a Friday afternoon? Well, one strategy is to use defensive checking. So we need to make sure that any point of time. So here, well, we check if the person is not null. In that case, we can extract the car. Then we check if the car is not null. In that case, we can extract the insurance. Then we need to check if the insurance is not null. And then finally, we can extract the name of the insurance. And this is really unfortunate because, the intent of a code now is really hidden through all this defensive checking. In addition, it's not really clear whether we're adding all those checks to fix a bug or whether there is a real meaning to it. So how can we refactor this code to have something a bit better? Well, Java 8 introduced a new class called Optional. If you're familiar with the Guava library, there is also a very similar optional class. So what the optional class is, it's basically a way to represent a single value container that could contain a value or could be empty, in which case it means it doesn't contain a value. And this is really great because it enables us to do explicit modeling. By saying that, well, a person has an optional car, it's immediately clear that he may or may not have a car. And this, explicit modeling is better for maintainability. But the optional class provides us with a bunch of methods to explicitly deal with the case where there is or isn't a value. So it means we can't forget about it. If we have to check for null, then typically we forget to check whether a property could return null. With an optional, you have to explicitly deal with the case of the absence or existence of a value. So let's see how this works in our code. Well, the first step is to update a model. So here we've got a person which may or may not have a car. So this is why we explicitly say a car may or may not have an insurance. Now, I know what you're going to say. Well, in UK, every car has an insurance. Well, this is true, but maybe in some other countries, they may not have an insurance. I'm sure we can all think of some places where driving may be a bit more dangerous than in UK. And then finally, we've got the insurance that, well, it needs to have a name. There is not such a thing as an insurance without a name. So this is why we are not stating that the name field is optional of a string. This is explicitly saying it needs a name. So this is a great way to differentiate in a modeling. So how can we refactor code now to use this new optional class? Well, there are several methods that are available to us. One of them is called map. So what map does is it takes as an argument a function on the value wrapped in the optional. So let's say we had an optional of an insurance. We like to extract the name of it. Well, we'd call the method map and passing as an argument the getName method. So again, this is a method reference which I showed in the first part of the webinar. And here it would extract the string. If the optional was empty, then the map method will return also an empty optional. There's another method called flatMap, which is useful. So the way to differentiate between map and flatMap is as follows. So let's say we had an optional that contains a car. If we were calling map and passing the car get insurance on this, then that would return a nested optional structure. Because remember, the getInsurance method was refactored to return an optional of a car. So which means the result would be optional of insurance. And this is the crazy, and that's one of the major reasons why Wally quit his job and went on to hide with large groups of people. So there is another method to help here called flatMap, which nests the optional structure. So when we've got a method that returns an optional object, then we can call flatMap, and in this case, given an option of a car, it returns an option of an insurance. So let's refactor our previous example to use this optional feature. So here comes a good old getCarInsuranceName method that takes a person. The first thing we do is to create an optional of this person. So there is a static method called OffNullable, which takes an object as an argument and returns an optional version of it. So if person was null, then this will return an empty option. The next thing we'd like to do is to extract the car of this person, which may also be optional. This is what we call flat map. The result of this first flat map call will be an optional of a car. So the person may or may not have a car. The next thing we'd like to do is to extract the insurance of that car. Well, the getCarInsurance method also returns an optional of an insurance, right? The car may or may not have an insurance. This is what we call flat map. And finally, once we've got an optional of insurance, we'd like to extract the name of it. And we know that the getName method always returns a string because an insurance needs to have a name. And this is why we call this map method. So the result of this will be an optional of a string. And this is where, optional is really useful. So in the case where any of those methods return an empty optional, meaning, well, there isn't a value, we can always have a default case. And there is this method called OElse that lets us provide a default value. So this is a refactoring exercise. And if you use optional, consistently can replace the use of null and lets you avoid typical null checking bugs. Right, so it's now time to conclude and summarize what we've seen so far. So we've introduced first-class function, which is a functional programming technique which lets you cope for requirement changes. So that was the idea of passing a function as an argument to another function, just like we're doing it with normal values like numbers and objects. Currying was the idea of splitting the parameters of the function to reuse code logic. Another way to think about the benefits of it is to think of it as a factory of functions. Immutability reduces the scope for bugs where you can't change the state of an object anymore. And optional data types lets you reduce null checking boilerplate and prevent bugs. So, we've evolved now a little bit. The trend now is to incorporate a little bit of techniques from multiple different paradigms. So it's not just about object-oriented programming. There are some interesting ideas also from functional programming. So a lot of languages these days kind of merging towards this idea of maybe let's take industrial ideas together with more academic ideas. So this is why I really like this new Lego guy, which is a little bit of a merge. If you'd like to find out more about Java 8, we provide a 2-day Java 8 training courses that will go through all the Java 8 features and show you how you can write more flexible and robust code. I recommend 2 books. The left one, called Java 8 in Action, is a reference book about Java 8. It covers all the features and also has 3 chapters on functional programming, including an introductory chapter to Scala. So that's the one I wrote on the left side. A good friend of mine called Rich about Java 8 with O'Reilly's called Java 8 Lambdas. So it's a shorter book and I also recommend it. Finally, here's a little plug slide. I've created a new initiative called the Cambridge Coding Academy to teach the young generation how to program. Have a look. I'd like to thank eSynergy Solution for organizing this webinar. I hope you enjoyed it. If you have any needs for recruitment and any roles, please contact them, Neil and Adele. I'm sure they can help you guys out. And thanks. I'll now look at all the questions you guys have given me. Thanks so much for the participation. All right. So let's see why it is not an abstract class. Right. So previously I introduced this predicate interface that has methods inside it called and or. They both had implementation code. So there is, I guess, a sort of blurry line between what is an interface and what is an abstract class in Java 8, since they can both have implementation code. And there's 2 key differences to keep in mind. The first one is, even though they can both have implementation code, interfaces can be multiply inherited, whereas you can always only extend from one abstract class. So that's a key difference. As a API designer, they provide you with a different power. And the second difference is that with an abstract class, you can always enforce a similar state because classes can have fields and state, whereas with interfaces, you can't really have that. And private final, static final fields are unrecommended. Next question from Christian. That feels and is it similar to jQuery? Okay, so the Streams API introduced in Java 8. So if you want to find out a bit more about the Streams API, please read my book or my previous presentation available on the website. We had a previous webinar with an eSynergy solution as well that goes over it. And yes, it gives you kind of a SQL-like query power. And it doesn't really lead to spaghetti like code. So this occurs really when we've got nested functions, and this does not occur with the Stream API. Next question, when should we use Lambda expressions? So Lambda expressions are really useful and concise when you just want to have a little piece of code that you like to pass as an argument or store in a variable. Typically, if the body of that Lambda expression is more than a line or two, then we leave a pause and you may want to extract that body into a separate method and then maybe use that method as a method reference. Wow, lots of questions coming, guys. Keep them going. This is really awesome. Christophe, yes, can we call it function factory? So one way to think about currying is to think about it as a factory of functions, yes? How do you pass the value to convert? So I showed an example in the current slides where we had this convert method. I think the next slides should have clarified that. So we passed the conversion factor, the baseline adjustment, and that was returning a new function. How does currying differ from adding methods with less parameters on top existing method with more parameters? Mahmoud, I don't really understand your question, so if you could please clarify it or send me an email at Raoul@Urma.com, I'll be happy to clarify that. How can we avoid defensive checking in earlier versions of Java? So the Guava API provides a similar optional class which you can use, and it does not require Java 8. So you can always use libraries to help you. Can we get this lecture video? Yes, guys. eSynergy solution will make the video and the slides available straight after I'm done with replying to your questions. So another very interesting point is Java could have introduced Groovy's Elvis operator, which allows us to traverse safely a chain of method calls that may return. So it's worth mentioning that actually the Elvis operator was considered for Java 7. So there's a lot of discussion on the mailing list with the reasons why it wasn't introduced. So Adarsh Ramamurthy, again, if you follow up with me, I cannot provide you with that link. Can we get the slides? Yes, they will come very soon. I think in the next 10-15 minutes, Adele will follow up. Same question for Ben. Matt Gregory, excellent presentation, no questions for me, many thanks. Thank you very much for the kind words, Matt. So another question is, well, in that case, abstract keyword would be going obsolete. So the abstract keyword is still useful for abstract classes. And as I mentioned in the previous answer to a question, interfaces and abstract classes still differ on two fronts. Jerome, how do you pass the value to convert to a curring method? I don't understand this question, so again, if you can follow up with me after this. I think I clarified that during the slides. Does Java 8 solve the diamond problem? From Adnan Rouge. So this is a great question again. So because interfaces can be multiply inherited and they can have implementation code, you know, it's fair to think, well, C++ has that feature, and it's really bad because we've got this diamond problem where we inherit from multiple locations. What if we inherit from the same method with the same name and so on? So Java 8 does have resolution rules to prevent this type of scenario, and I invite you to read my book, which has a dedicated chapter to default methods, and go in depth on this problem. Is Java 8 going more of a Scala way? From Dianesh Sonwani. So this is a fair question, and there is a convergence from language designers to adopt more and more functional programming features. And the reason is because they're starting to prove themselves in industry large code bases. So Java 8 will not go the full Scala way, you know, you're never going to hear about monads and so on, but it's definitely adopting more functional features. So languages these days kind of have a merge between functional programming and object-oriented programming. For example, C++ also supports lambda expressions. Would you believe it? So, yes, from a Sakshi Shingal, guys, I hope I'm pronouncing correctly. So, regarding currying, is it similar to the builder design patterns? Yes, you can think of it as also the builder design pattern when you do a chain of currying. So a factory, you know, you produce a function which itself could produce another function and so on in a chain. You could think of it as the builder design pattern. Yep, that's a good analogy. I would like to have more info about the Java 8 course. So as I mentioned earlier, we provide a 2-day training course that goes in depth over all Java 8 features. You just need to go on java8training.com and you'll have all the information, all the content, and pricing information. Feel free to send me an email. So if you go on my website or tweet at me, I can provide you with this information. And Adele will send you this information as well at the end of this webinar. Lots of questions, guys. Wow, there's lots of interest. This is very exciting. What will happen if inheriting multiple interfaces and those have same default method? So I believe I answered that question. So Java 8 has resolution rules that prevent those types of problems. How similar is Java 8 to Scala? What advantage does Scala offer? We weren't wanting to plug too much again. In my book, there's a chapter that compares Scala to Java 8, so I invite you to read it. But in a nutshell, Scala has more features such as pattern matching, which you can think of it as a less verbose way to do the visitor design pattern. It has more features around functions and immutability, and it lets you write code with less verbosity. So I recommend to check it out, you know, just to see what's out there. Is the Streams API thread safe? It's thread safe if you use it the right way. That's my answer to it. What I mean by that is that you should avoid any sort of side effects. Again, this topic is covered in my book in details. Java 5, coming from Raj Kapoor, Java 5 was a step increase. Java 6 not so much. Not sure if Java 7 was. Is Java 8 a step increase? Yes, Java 5 was a major step increase because it introduced generics. So any API you see these days has generics all over it. So that was a huge contribution. Java 6, yeah, didn't include much interesting things. Java 7, well, introduced fork join framework, introduced a couple of features, such as, generics inference. So it's not really a step change, no. But Java 8 is a major step change. It really sends a strong message to us, the community, is that functional is cool and functional is useful. And you can benefit from it as a software engineer. And I hope that I've shown that in the presentation. You can code for requirement changes, write more concise code that's more maintainable and readable. So it's worth the leap. Coming for Spencer Loveridge, are any of these syntactic changes more performant? So I assume, Spencer, you're discussing about lambda expressions. Are lambda expressions more performant than using maybe anonymous classes or traditional classes? And the answer to that is yes. In the worst scenario, lambda expressions perform exactly as before, as traditional ways. But in certain scenario, when lambda expressions are what we call stateless, so when they don't have side effects, then they perform better because the cheat compiler can cache those definitions of lambda expression and uses them. Whereas if you were using anonymous classes, you always have to do a new allocation of it. So there are optimizations going on behind the scenes as well. Roland Ball, what about offer on your book? Yes, my book is available on Amazon, UK.com, also on the manning.com website. If you email me, I can send you guys a special discount for attending this webinar. Raj, thanks Raoul, thanks Raj for coming. Christian Busy, in the current example, there was the amount variable that was not passed as a parameter. Yes, so the amount variable was not passed as a parameter, it actually was passed as a function. So the convert method was returning a function, and that function was taking the amount parameter and using it to apply the conversion logic. Stephen McManara, actors. So there are APIs and libraries that uses actors. So a really proven one in the community at the moment is called Akka, so A-K-K-A. We won't have syntactic sugar to work with actors though coming in Java, but Scala, the way it's defined, lets you have some syntactic sugar around it. So if you want to play with actors and different concurrency models, there's plenty of APIs and libraries in Java, but there won't be any sort of syntactic sugar to work with it. Chris, thanks for your presentation. I missed the first part of the presentation, but we'll look out for the slides. Also, good work to eSynergy for taking this initiative. Thank you, and yes, a great initiative from eSynergy to organize those webinars. I'm sure you guys want some more, so feel free to email what sort of topics you'd like to be discussed, and I'm sure we can put something together for you guys. Kristen, you looking forward to use it? Yes, I'm glad that we've generated some interest on it. Stephen, yes, actors from Scala, which I mentioned a couple of minutes ago. Thanks for the answers. My pleasure. Is Java, coming from Stephen, is Java trying to supersede Scala? So I need to be slightly careful here because, from a political point of view, not sure what we can say, but Java is definitely not trying to supersede Scala. I think they're both different use cases. So if you want stability, if you want something that's proven and safe and that's not going to change the next day and break your code, Java is the way to go. Scala at the moment, still introduced quite a lot of backward incompatibilities, which are very unpleasant. So let's say you write some code today, in 6 months it might not compile because an incompatibility in the language was introduced. So I think what the Java community thinks of Scala is that it's a great language that acts a little bit as a playground for a number of features that are waiting to be proven. And once they're proven, they get incorporated in Java. And 2 examples of that are lambda expression and the streams API. which have been available in Scala for a while. So my advice is I strongly recommend checking Scala. Just from a conceptual point of view, it's always interesting to see what's outside the Java bubble. There's a lot of interesting ideas that makes us a more complete developer. But whether you like to use Scala at work or not, it's entirely up to you. But a lot of companies are doing it these days, such as Twitter and several banks. From Karan, hello, thanks for your seminar. Did you face any sort of problems when you try to migrate any existing application already written JDK 7, JDK 6, etc. to JDK 8? So Oracle publishes compatibility guides that says what are possible incompatibilities. So in general, they're always minor and affect a very, very small % of users. So you might want to check it out. If you don't know where to find them, please follow up with me and I'll happily provide you this information. So my PhD thesis is about backward incompatibility and related topics, so I'm I'd be glad to provide some information on that. So in the end, Java 8 follows the older C++ in allowing their own sort of multiple inheritance from Christian. So, you know, multiple inheritance is a mechanism that exists in a lot of languages, including Python, C++, I believe even PHP, so it's not really new. How C++ differentiates is that it allows multiple inheritance of state. So you inherit from classes. So if a class has the same, two classes define the same field, it's very difficult to know, well, which field should I inherit from because they both have the same name, so it's a bit tricky. But because interfaces don't have state, then the C++ problems do not occur. And when there's name clashes with methods, Java 8 provides some rules to prevent that. Typically, it's a compile error, which you then need to rename a method. What is the benefit? Okay, cool. A couple more questions. I think four questions left. So from Anand, what is the benefit of using Java 8 parallel streams versus explicit multi-threading? So great question. And in general, multi-threading, you know, is very hard. It's very Bose. It's very easy to introduce an error, which, you know, like a data race, which is very hard to debug. So writing multi-threaded code is really reserved to a niche of users, expert users, and even experts make mistakes. So what Java 8 does is hide away all that complexity through an API that lets you do various data processing, and behind the scenes it can figure out how to optimize the computation. So in a nutshell, it's giving multi-threading to the wider sets of users without having to worry about all the possible errors and complexity behind it. So Brian Hunt, what's the email for the book discount? So the email is Raoul, so R-A-O-U-L at Urma, U-R-M-A.com. You can find all my contact details on my website as well, which is urma.com, so urma.com, and Adele will follow up as well on this. Same question from Dinesh. Wow, so lots of people want to read my book now. This is really great. Hope you enjoy it. So from Christian again, there's a lot of Scala talk, but Scala does not compile to Java bytecode in yet. So Scala does compile to Java bytecode and runs on the JVM. So typically Scala can use a lot of existing Java APIs. Okay, Christian, I've got your email as well. Srinivas, your comments on DSL in Java. So we've always been able to create DSL likes in Java, right? Unfortunately, it is really verbose because Java didn't have concise features. For example, to pass function as an argument. So lambda expressions here can help create more concise code. So they will definitely benefit DSL designers. Brian Hunt, thanks. Yeah, awesome. Thanks for coming. So Christian, no multiple inheritance not new, but Java. So yeah, Java does not support. Yeah, exactly. It's worth mentioning. Java does not support multiple inheritance. By that we mean full multiple inheritance in the C++ way, but it supports multiple inheritance of behavior. So inheriting from multiple implementation of methods. Stephen, yes, indeed, you spelled my email correctly, Raoul@Urma.com. And I believe that's the last question. If there is any remaining question, I can stall for time for a few more seconds. Thomas, yes? Is there a chance that the new Java 8 Lambda constructs conflicts if used with the Scala code? There are some scenarios where you can get some conflicts. It will require a 5 minutes discussion, so if you can follow up with me, then I can explain to you when those conflicts can occur. But in a nutshell, Lambda expressions rely on what we call functional interfaces, and a functional interface is an interface that defines one single method, and it is possible that we can have several functional interfaces with the same signature, and so that could produce some conflicts. So if you follow up with me, I can give you those use cases. And typically it occurs when we've got overloaded methods. So let's say a method takes one functional interface that has a specific method signature, and the same overloaded method takes another functional interface as an argument. Then it's ambiguous which functional interface we should choose. So that can create some conflicts, and some Scala code might use this pattern. All right, guys. So I think that was the last question. So again, thanks for listening, and please follow up with me. I'm very happy to answer your further questions and the book discount related and training stuff. Thank you. So I think